Thank you. My name is Francisco Batlle, and I will present you another kind of water. First of all, it is well known that water is scarce and then a source of conflicts, and maybe that's why the Water Framework Directive said that it has to be public participation, monitoring intense, and active management. So it fits perfectly well with the concept of open data. Remote sensing gives us information about surface water, meaning also ocean, rivers, but, and there's always a but. The bad thing is that human beings usually use groundwater. Global groundwater is scarce, and it cannot be seen from the outer space. There has been attempts to check it from the remote sensing from satellites like GRACE with gravity data, but it's not enough, and it computes the total amount of water, which is useless and a very coarse grid. So we claim that the only way to have this spatial information about groundwater is to use numerical models so that we can assess the natural evolution of water bodies. And also, all this remote sensing information of surface water will be very valuable for us to do this groundwater modeling. So we would like to join this club of open data. In order to do this, we'll try to imitate this satellite information for groundwater. So they told us that if we want to join the club, we had to link this as open data. So we tried to derive an ontology using well-known and well-used, widely used standards like WaterML from OGC and Quasi and VTK. So we make this open data, and we put it for the public in web services so that public can ask for certain data of any groundwater information that governments would like to show it available. But if we want to mimic, if we want to imitate really the satellite information, we'll have to make scenes, make information as time evolves. And now that's where the cloud came, and what we do is we take not remote, but local sensing data, we put it in the cloud. Every time that we get new information, we instantiate a new virtual machine, we run it, the model, and again we get the results and transform them to linked open data. 2 years after we started with the project, GEOS came with a vision that fits perfectly well with what we are doing, which is the vision of model web as a basis for the development of a dynamic web of models, integrated databases, websites, and so that people can gain insight putting into what-if scenarios with questions. We have done proof of concept in Barcelona aquifer, which is one aquifer that supplies half of the population of Barcelona. It has also seawater intrusion, so we have to deal with it. Our model deals not only with the quantity, but also with the quality, well, only chloride of water. And with the help of University of Athens, we put it in a database, a Strabon database, make a portal, and make all these web services in order that you can test, the public can test, not only the time series evolution, but also the model results evolution for every time step. We have also expanded this proof of concept to other places, along with the Melodies project in Spain, Panama, and Chile. in Santiago, but we wanted to go beyond this model web paradigm, and we wanted to extend. We were really upset with all these smart cities, always everybody talking about smart cities. What about the smart regions? So we built up a small application, public application, you can get it in GitHub, and in which the user can check all the sites with information and see the evolution of the water table, the water depth. And even in those places where there is no well information, you can ask the model to predict which will be the water depth. Well, this is not an issue, but thanks to the University of Reading, we have also the possibility to put in our application also the contours of, for example, chloride or level. But the real issue that we would like to go further was this, what we call numerical models 2.0, which means that people can give their data if they think that the data that we are giving them is not correct. That means that if someone has a well, their own well, and he or she knows where the water table is, he or she can give us the current value, the good value, and this value will improve the model. It's not so easy. These equations are only to say, hey, it's not easy. But the main thing is that what we discovered is that the values that the people are sending us, the first value is not useful for us. We don't know where the user has measured the water table from. We are not absolutely sure that it is measured from the strict ground. But the second value is of much more use for us. So we check the trend, and we include the trend in our calibration analysis, the increment actually. So to conclude, because everybody wants to go to lunch, innovations. From a general point of view, we try to treat numerical model results as if it was satellite data, so that we can integrate all the numerical model results with other remote sensing, seamless, as other remote sensing process, and join this data in order to improve the model. As we wanted to imitate this, let's say, satellite data coming as new data are available, we also have discovered that we have reactivated previous existing models that were done only on a, let's say, on a planning phase, and then it has become more valuable. It has really made it an active resource. Then we also, on a more specific side, we converted groundwater data as linked open data, expecting that sometimes, somewhere, more data will become available as linked open data that will facilitate the join of these values. Model web, which is this paradigm that says that the model is in the web, that you can consult it, and that you can even put what-if questions to it, is now not only a GEOS vision, but a small reality. And finally, we tried to leverage all these smart city tools to smart city regions so that public information can be extended not also to the citizens, but also to the citizens out of the city. And the thing that we like the most, even though it is now only directed to small number of people, is this model driven by citizen data. It's the participation in both directions. The public not only gets data, but also contributes to the model. In a sense, they are having a shared ownership of the model so that we can build trust between water stakeholders and reduce all these water conflicts. And that's it. Thank you very much.
Francisco, just a practical question. How many people in general, let's say in the Barcelona test case, do you actually have a regular interaction with for the modeling?
Yeah, we started right now with it, so we cannot give you figures, but there's no so many, say, potential people, only those people that own wells in this small region. That's about 1,000 persons. So as long as we get numbers of people sharing information with us, we will put it in our web.